Example 1, confidence interval for claim about two means. Are people getting taller? Listed below are heights in millimeters of randomly selected U.S. Army male personnel measured in 1988, and different heights, millimeters of randomly selected U.S. Army male personnel measured in 2012. Construct a confidence interval estimate of the difference between the mean height in 1988 and the mean height in 2012. Okay, now so before we go any further, there was a correction here of one of the values, and this should be 1734. Okay, so the first thing we want to do is we want to be able to first identify the following. We're going to let the 1988 be population mean 1, and we're going to let answer 2, 2012, be population mean 2. So we want to use StatCrunch to find the sample mean of both samples, the sample standard deviation of both samples, and the sample size of both samples. So what we're going to do is we're going to come in here, and what you're going to want to do is you're going to enter in the data. So you title the first column for sample 1, and then the title of the second column, sample 1, and we're going to put all the values in. Now once the values are put in there, we're going to go to Stat, select Summary Stats, and select Columns. And then we're going to select both of these columns, and then we want to find the mean, standard deviation, and the sample size, and then select Compute. Now we're going to go ahead and then copy this and make sure that we write down the information given here. So here we have our information. So we can see that we get the mean to be 1739.417, rounded to 3 decimal places. The sample mean for the second sample is 1777.8. And then sample standard deviation for 1 is 66.601199. Sample standard deviation for sample 2 is 47.866183. We can see the sample size for sample 1 is 12. The sample size for sample 2 is 15. Now we need to check the requirements. Now the values of the two population standard deviations are not known, and we are not making an assumption that they are equal. Number 2, the two samples are independent because the measurements are from different people, and they are not matched or paired in any way. Number 3, the samples are simple random samples. Number 4, both samples are small, 30 or fewer, so we need to determine whether both samples come from populations having normal distributions. So in order to do that, we're going to come back in here and open up StatCrunch. We're going to go to Graph and scroll all the way down to where it says QQ-Plot. And then what we're going to do is we're going to select both columns, and then just make sure we select the horizontal and vertical lines, and then select Compute. So if we take a look at the first sample, which is 1988, we can see that this represents an approximately normal distribution. If we look at the second one down here, if we scroll to the right, we can see for 2012, again, this represents a normal distribution. So the normal quantile plots of the two samples suggest that the samples are from populations having distributions that are not far from normal. Therefore, all requirements are therefore satisfied. Okay, now we want to be able to find the critical value. Okay, so we want to take a look at the confidence level for the confidence interval. So what do we know? Well, we first need to take a look at the degrees of freedom. We're going to use the simple and conservative estimate. So we know that sample size 1 is equal to 12, sample size 2 is equal to 15, and so therefore sample size 1 is less than sample size 2, and the degrees of freedom is going to be the smaller of those two. So the degrees of freedom is going to equal 12 minus 1, which is equal to 11. Okay, now the claim that the mean height of the 1988 population is less than the mean height of 2012 population can be tested with a 0.05 significance level. Okay, so again, we're constructing a confidence interval, and so since we are looking at a 0.05 significance level, we're going to construct a 90% confidence interval. So 0.05 here gives us a 90% one-tail test, since it's a one-tail. So we first need to find alpha. Well, alpha is going to equal 1 minus 0.90, which gives us 0.10. And then we're going to take 0.10 and divide it by 2, which gives us 0.05. So now I want to be able to find that positive critical value where the area to the right is 0.05. So if we open up StatCrunch, we can do the following. So we're going to go to Stat and go to Calculators and then scroll all the way down to T. And so what we want to do now is, because this is a degrees of freedom, we're going to put in 11. We want to put in the greater than or equal to, because we want to find the critical value on the right, and then put in the area here, which is 0.05, and then round it to 3 decimal places, we get positive 1.796. So the critical value is going to be 1.796. So now we have the degrees of freedom and we have the critical value. Now we can find the margin of error that corresponds to the 90% confidence interval. So we know that the critical value is 1.796. We know the sample standard deviation for 1, sample standard deviation for sample 2. We know that N1 is 12 and N2 is 15. And now we're going to plug it into the formula. So let's go ahead and take a look at that. So we know that the critical value, the critical T value, is 1.796. We know that the sample standard deviation for sample size 1 is 66.601199 squared. And then the sample size for sample 1 is 12. So we're going to divide that by 12. Okay, and then the sample standard deviation for sample 2 is 47.866183, and we're going to square that and divide it by sample size 2, which is 15. So let's go ahead and do this on our calculator. So before we do anything, let's make sure that we contain things in our calculator. So if we want to put this in our calculator, we need to add a second set of parentheses here and a set of second parentheses there. So now let's go ahead and do this. So we're going to start with the square root. So we're going to go second square root, and then we're going to have one parenthesis and then add another one so we can square this number, 66.601199. Close the parenthesis. We're going to square that number, and then we're going to divide it by 12, and then we're going to add the close the parenthesis. Then we're going to put the plus sign. Then one parenthesis and add another one for the numerator, which is 47.866183, and then close the parenthesis, square that number, and then divide it by 15, and then we're going to close that parenthesis, shift to the right, and then press enter. Now once we have this value, now we want to be able to multiply that by the critical value. So times 1.796, and that gives us the margin of error to be 41.049036, rounded to 6 decimal places. So therefore, there is the margin of error. Okay, now in step 5, we want to find the 90% confidence interval estimate of the two population means with the following. We know that the sample mean for sample 1 is 1739.417. We know sample mean 2 is equal to 1778.8. And we found the margin of error to be 41.049036. And then we're going to plug it in the following. So let's go ahead and take a look at this. So we have sample mean 1. So there's sample mean 1. There's sample mean 1. And we have sample mean 2, which is here and then there. And then we're going to then subtract the margin of error on the left side and then add the margin of error on the right side. So let's go ahead and do that. So we have 1739.417. We're going to subtract 1777.8. And then we're going to subtract the margin of error. Same thing on this side, 1739.417 minus 1777.8. And then we're going to add the margin of error. So let's go ahead and do that on our calculator. So for the first one here on the left side, we have parentheses 1739.417 minus 1777.8 in parentheses, and then we're going to subtract 41.049036. and that gives us negative 79.432036. Now, if we wanted to then do the same thing on this side, if you have the calculator, we can go ahead and just press enter, and then just change the margin of error, the sign next to it, over here to be a plus sign. And therefore it gives us this value. So if we round these to 3 decimal places, well, 6 decimal places, we get negative 79.432036, and then 2.666036. And now we're going to round it to 3 decimal places, negative 79.432 and negative 2.666. So this is our lower bound, this is our upper bound. And so now what we want to do is state the following. Now, if we use technology, the confidence interval limits of negative 77.9 and 1.1 are found from technology. They're more accurate because they don't round anything. But we can see that the manual calculations gives us a result that is reasonably good, even though we used a simplified method for finding the number of degrees of freedom. Now we're going to state the conclusion. Now, the confidence interval limits, if you look at the confidence interval, it's negative 79.432 to positive 2.666. So the confidence interval limit does contain 0, suggesting that it is very likely that population mean 1 minus population mean 2, which is equal to 0, suggests that there is not a significant difference between the mean height in 1988 and the mean height in 2012. So we would state the following. We are 90% confident that limits of negative 79.432 millimeters and 2.666 millimeters contain the true value of the difference between the mean height in 1988 and the mean height in 2012.